All right, this is problem 26 on chapter 18. It says a dentist uses a curved mirror to view the backside of a tooth. So this is going to be the backside of the tooth here, of an upper jaw. Suppose she wants to erect an erect image with a magnification of 2 when the mirror is 1.2 centimeters from a tooth. So we don't know how tall the tooth is, but we do know that this distance, the image distance, equals 1.2 centimeters. That's what it is in meters, by the way. It says treat this problem as though the object and image lie along a straight line. Use ray tracing to decide whether a concave or convex mirror is needed and estimate its focal length. So what we're going to try to find is the image distance as well as the basically I'm going to also calculate the focal point using the mirror equation and the magnification equation. That way I don't have to do the ray tracing. I mean, I did it anyway. I know what it's going to do, but that's kind of hard to show on here. So I'm going to use the equations to determine where the focal point is, and that will determine whether it's a concave or convex mirror. So just bear with me on that. So first thing we're going to do is find the image distance. And we're going to do that from the magnification equation. So the magnification equals the image distance, the negative of the image distance over the object distance. Let me put that up a little higher. A little more room that way. Okay, so we want to rewrite that. We know the magnification, we know that. We don't know the image distance. So using algebra, we get the image distance equals, so we times that, times by -1. So we got a negative of the magnification times the object distance. Okay, and we just plug in numbers. Magnification is a -2. There's a negative in front of it from the equation. Object distance is 1.2 centimeters. We plug that in, we get a -0.024 meters or 2.4 centimeters. That's our image distance. Now, we know that the image is going to be 24 centimeters over here. How will that work with the mirror? So sorry about that, got my daughter with me. So to do that, we'll find the focal point. We use the mirror equation of 1 over object distance plus 1 over image distance equals 1 over the focal point. So we want to solve for the focal point, so we'll just reverse this equation and get the reciprocal. So that turns into focal point equals 1 over 1 object distance plus 1 over image distance. So we plug in the numbers, get 1 over point, so object distance is 0.012 plus 1 over -0.024. And if we calculate that, we should get a positive 0.024. So positive 2.4 centimeters. So this was 1.2 centimeters away from the mirror. So the focal point is going to be 2 points. So focal point is going to be all the way over here. So that makes sense. So if we were to, so if it's going to be over here, that makes this a concave mirror. And we trace this. It's going to bounce straight out. This is going to bounce straight in and bounce towards that. So this is going to come out like that. This is going to come straight out like that. And we'll have an image over here, upright, of the tooth. It's going to be bigger. it's going to be virtual.